Hello everyone, my name is Junior Makubela. Today we are going to look at Mathematics Paper 1 and we are also looking at Chapter 1. This is a sequence and series. So basically on sequence and series, we have arithmetic sequences, geometric sequences. We also have quadratic sequences. And quadratic sequences, if you remember, you covered them in grade 11. And then we also have series, which is arithmetic series, geometric series, and infinite series. So basically, the difference between a sequence and a series is actually that a sequence is what you know, is a normal number pattern. Let's say, for example, we have 2 to 4 is 2 is to 6 moving forward. So when you see these commas here, this is what identifies a series, or not actually a series, I'm sorry about that, a sequence, or you can say a pattern. So the difference between a sequence and a series is that a series is actually an addition of all the numbers in the sequence. So if you write the same sequence but you write it as a series, you will say is 2 plus 4 plus 6 plus moving forward, all the numbers that will be coming after that. So that is the difference between a sequence and a series. So in a series, you will have to calculate the sum of all the terms, but then in the sequence, you can only calculate, let's say, for example, the value of the last term, of which it might be a 1000th term or a term that is far away. So the only thing that we're going to do in this lesson, we're only going to cover the first one, which is an arithmetic sequence, and then we will divide those sequences and series one by one like that. Maybe tomorrow we'll consider doing geometric sequence and all stuff. Actually, on the next video, we will cover geometric sequence and then quadratic on the next one, just like that. So, an arithmetic sequence. What is an arithmetic sequence? Okay, so basically, an arithmetic sequence is a sequence that has what? That can be added or subtracted by a same term throughout. I don't know if I make sense by that. I'm saying now, if ever you have an arithmetic sequence, you can either add the same number from a previous term to get to the next term. Let's say you have, let's ignore this one here. Let's say, for example, you have 1 is to 2 is to 3 is to 4. So basically, to identify this is a arithmetic sequence, you will see now you are only adding the same number throughout the sequence, which is 1. So 1 plus 1 will give you 2, 2 plus 1 will give you 3, 3 plus 1 will give you what? Will give you 4. So this is an arithmetic sequence. You basically add the same number or subtract the same number. The other one will be, for example, let's say 1 is to 0 is to negative 1 is to negative 2. Moving forward. So basically here in this case, you will be subtracting 1 from the previous term to get to the next term. Let's see here. If you have 1, 1 minus 1 is going to be 0, and then 0 minus 1 is going to be negative 1. The negative 1 minus 1 is going to be how much? It's going to be negative 2. So that is how you see an arithmetic sequence. But actually, there is what we call a constant difference, of which is the one that helps us to identify if ever our sequence has a constant number that we are adding with throughout, or that we are subtracting with it throughout. So we call this a constant difference. So how do we identify this constant difference? The constant, we will see now, the difference between two consecutive terms must be constant. Ne? So let's say, for example, you have this sequence here, which is 6, 13, 20. So if the difference between two consecutive terms are equal, then we can say what? Our sequence is an arithmetic sequence. That means we will be adding or subtracting the same number throughout the sequence. So how do we check if our constant difference is the constant or the same? Let's say now we have term 1, and this is our term 2, and this is our term 3. So basically, the difference between two consecutive terms is between what? Term 1 and term 2. Those are consecutive terms. They're terms that are close to each other. And then consecutive terms between, the other ones will be what? Between term 2 and term number 3. Those will be what? Consecutive terms. Terms that are close to each other. So now let's see if ever the difference between these consecutive terms is constant. So basically the difference between these two terms must be the same as the difference between these two terms. Yeah? So when you actually identify the difference between two consecutive terms, make sure you start with the term that is in front, and then you subtract the term that is at the back of it. Meaning now you will say term 2 subtract term 1, which is what? Which is a difference between term 2 and term 1. You check if ever is equal to the difference between what? Between term 3 and term 2. So if this condition is true, then you can conclude now to say what? This is an arithmetic sequence. So now you will substitute the value of term number 2, which is how much? Which is 13. Subtract term number 1, which is 6. Then you equate it to term number 3, which is 20. And then you subtract term number 2, which is 13. So on our left hand side, we will say how much? 13 subtract 6. If you say 13 subtract 6, you will get how much? You will get the value of 7. So basically also on the right hand side, it will be 20 subtract 13, of which you're going to be left with what? With 7. So now we can see now the difference between what? Between the term 2 and 1 is actually how much? Is 7. And then also the difference between term 3 and term 2 is how much? Is 7. So the difference between two consecutive terms is actually what? Is constant, is equal. That means now the sequence is a what? Is an arithmetic sequence. So now this difference that we have, we're going to represent it by what? By D. The value of D will now be equals to 7, because we have identified now this sequence is a arithmetic sequence because it has a constant difference of which is 7. Okay. So if you have an arithmetic sequence, there's actually a formula that you use to determine what we call a general term. So basically, a general term is an equation or a formula that can help you identify, maybe let's say, for example, you want to find the value of a term that is at position number 1000. You can't always add 1 or maybe let's say, for example, 3 to the previous term so that you can identify the value of a 1000th term. So basically this equation will simplify your work. With this equation you can get the value of that 1000 term by just plugging in the missing variables. So here is the formula. The formula is what? Is Tn. The general term of an arithmetic sequence is equals to A plus n minus 1 multiplied by difference. On this general term of ours, the value of A represent what? The first term of the sequence. And then the value of n represent the position of the term. And then the value of d represent what? The difference between consecutive terms. Remember, this equation can only be used if we have an arithmetic sequence. So basically, we will always have what? A constant difference. Because if a sequence does not have a constant difference, then it's not an arithmetic sequence. So this difference is only on an arithmetic sequence. And then now the value of Tn will represent what? The value of the term. Let's say, for example, you are given, let's say a term is on term number 3, which is n, and then this Tn represents the value of that term, of term number 3. Let's say, for example, we have a sequence like this. Let me just say 4 is to, let's say 6, make a simple one, 8, moving forward. So now, from this sequence of ours that is given to us, we can easily identify the value of A, because A represents what? The first term of the sequence. So now we can easily identify the value of what? The value of A. The value of A is equal to 4, because the value of A represent what? Represent the first term of the sequence. But you can't say, okay, it doesn't matter if ever is an arithmetic sequence or it's a geometric sequence. The value of A will always represent the first term. But if ever it's a quadratic sequence, it's another issue. But you have dealt with quadratic sequences in your previous grade. So now you have to identify now if ever this sequence is a what? It's a arithmetic sequence. By checking what? By checking if ever now the difference is constant. You will say what? You will say term 2 subtract term 1 is equals to term 3 subtract term 2. So now this will be our term number 1, this will be our term number 2, and this will be our term number 3. So we'll say now term 2, which is how much? Which is 6, subtract term 1, which is 4, then equals to term number 3, which is 8, subtract term number 2, which is 6. So 6 subtract 4 is going to be 2, and then also 8 subtract 6 is going to be 2. And therefore now we can say what? We can conclude to say now our difference or is constant, and then the value of D is going to be 2. So now remember, you can't just conclude to say this is an arithmetic sequence without first checking if ever the difference is constant. That one is very much important. You must first identify if ever this sequence has a constant difference, and this is the formula that you use to check if ever this sequence has a constant difference. So now that you have identified the value of A and the value of D, then you can find what you call a general equation or a general formula of the sequence that we have. Let me just rewrite the sequence of ours. The sequence is what? Is 4 is to 6 is to 8. Moving forward. Now you just substitute the value of A and the value of D. You say now Tn will be 4 plus n minus 1 all multiplied by 2. So when you simplify here, you're going to have 4, and then these 2 will multiply n, then you will have plus 2n, and then also these 2 will multiply with -1, of which you will have -2. When you simplify further, your general term will be what? Will be n, and then 4 subtract 2, which is how much? Which is +2. This will be your general term. So with this general term, you can actually determine the value. Let's say, for example, they say calculate the 10th value of the sequence. So now you will do what? You will plug in the 10 on the where you see n, and then you will get the value of what? Of the 10th term. Okay, let me just make that example. Let's say now the question says what? Calculate the value of 10th term. Now you will say now, or the 10th term will have a value of how much? Of 2, because we now know the position is what? Is the position at 10. The value of n will be 10, and then you say plus 2. Therefore now the 10th term will have the value of how much? 2 times 10, it will be 20, plus 2, which is how much? Which is now 22. Now you can determine the value of the 10th term. So you can see now, if you are given, let's say for example, identify the term, the 1000th term, you won't need to add 2 from previous term to get to the next term, but you can just plug in on this general term to identify what the value of that term. And then you can also, they can also say, for example, let's say they give us 2000. They say find the position of a term that has a value of 2000. So you will do the very same thing here, because you have your general solution or your general term or your general equation. You will be able to substitute that value of what? Of the position, and then you get the value of n, which will be the position at which the value lies in. Okay. So here is an exam question that you will have. Let's say, for example, you are writing an exam. They will give you questions like this. So the first one, they say what? Determine a formula for nth term of a sequence. Okay. So let's say now they give you a sequence like this. 4 is to 9 is to 14. Moving forward. So now the question says what? It says you must determine the nth term of the sequence. The nth term represents what? It says a general equation or the general formula of this sequence. So you see, when they ask you this question, they don't tell you now this sequence is a geometric sequence or an arithmetic sequence. So the first thing that you do, you have to check if ever is this sequence a what? A geometric sequence or an arithmetic sequence. Yeah? So how do you do that? You will first check if ever this is what is an arithmetic sequence by identifying now this is our term 1, this is our term 2, and this will be our term number 3. So now you use the formula that you use what? T2 subtract T1 is equals to T3 subtract T2. You remember that for our sequence to be to be an arithmetic sequence, we must have a constant difference. So we check if ever now the difference between two consecutive terms is a constant difference or what? Is the same difference through all out or what? So the second term has a value of how much? Of 9, and the first term has a value of 4. And also we check what? The third term has a value of 14, and the second term has a value of 9. So basically you will say now 9 subtract 4, which will give you what? The value of 5. And then also 14 subtract 9 will give you what? The value of 5. So basically from here we can conclude to say now the sequence that we have is an arithmetic sequence because it has a constant difference which is equal to 5. So now we know our constant difference is 5, and then we know now the sequence is what? Is an arithmetic sequence. And then what else do we know? We also know the value of A, because remember now, the value of A is the first term of the sequence. Every time, the first term of the sequence represents the value of A. This is 4 here. Let me just write this A nicely. Sorry about that. So the value of A, will be equal to 4, because A represents what? The value of the first term. So now, how can we answer this point to determine what? The nth term. Remember, the nth term is a what? It's a general formula for this sequence, of which we have already identified. Now this sequence is a what? Is an arithmetic sequence. So if we have an arithmetic sequence, our general term equation is a what? Is Tn is equals to A plus n minus 1 all multiplied by D. So now we can just plug in the values that we have identified, or that we have calculated, which is the D is equals to 5 and then A is equals to 4. So when we plug those values, we'll have Tn equals to what? Is equals to 4. The value of A is 4. And then this will be n minus 1. And now the value of D will be 5. And then we simplify. You see we have 4. Then when we simplify here, we're going to see 5 multiplied by n, which is going to give us 5n. Then we're also going to say 5 multiplied by negative 1, which is going to be negative 5. And therefore, we simplify further, the value of the general term, or actually the equation of a general term, will be 5. And 4 minus 5, it will be what? It will be minus 1. So now this is what? This is the equation of the general term. I'm just going to write this equation of a general term here, because we're going to use it later. Tn is equals to 5n subtract 1. So now let's move to the second question. So the second question says what? Calculate the 21st term of the sequence. So now they wanted the value of the what? Of the 21st term of the sequence. So now you will say what? You will say, okay, now we have our general term, of which is this one. Remember, this is our general term here at the top. So now they say what? We must calculate the 21st term of the sequence. So basically, they want the value of the 21st term of the sequence. We will say T21, because they have given us the position, which is n. Remember, n represents the position, and Tn represent what? It represents the value. So they have given us a position which is 21. So where we see n, we substitute 21. Subtract 1. So this is a general equation that we have. And then they say we must determine the value of what? Of the 21st term of the sequence. So this 21st term is actually a position of which that term is. So now the position is what? Is n. We'll say in place of n, we'll put 21. Where we see n, we put 21. And therefore term number 21, T21 actually says term number 21 will have the value of how much? It will be 5 multiplied by 21, subtract 1. It will have the value of 104. That is how you answer number B. So let's answer the last one, which is number C. So number C says what? Says what? Now, determine which term of the sequence is 97. Basically, they're saying now, determine which term of the sequence has a value of 97. Now they have given us the value of the term. We need to find what? The position where the term is. So now, we are given what? Tn. We have to find the value of what? The value of n, the position. Determine which term, the position, which position has a value of 97. So now, from our equation, remember this is our equation, I'm just going to substitute here. Our equation is Tn is equal to 5n minus 1. So they have given us the value of Tn, which is how much? Let me just write here so that you can see. Tn is equal to how much? Is 97 equals to 5n, because now we don't know the position. They did not give us the position, they just give us the value. We determine the position, which is n. Just put n there, and then from here you just simplify. You transpose 1 to this side, is going to be what? It's going to be positive 1, and therefore 97 plus 1 is going to be 98. Then you will be left with what? With 5n. Then you divide both sides by 5. You divide both sides by 5, and therefore the value of n will be, let's check here, 98 divided by 5. So the value of n will be 19.6. So now the value of n is 19.6, but we know now the position of the term, it can be represented with a number that has a decimal, or it has a decimal there. So you need to round it off. So we can see next to the comma we have 6. Then we will say now, therefore the position of the term, it will be at what? Term number 20. Okay, thank you very much. We're just gonna end here for today.